Hey everyone, today we're going to be moving on to section 3.3 and talking about something that you've probably heard of in your life, and that is a box and whisker plot. Maybe back in like 5th, 6th, 7th grade, you were asked to interpret these things before. Turns out it does have some usefulness as we get higher in statistics as well. It's a good way to summarize the spread of the data. So let's go ahead and jump in. In order to create a box and whisker plot, you need what we're going to call a 5-number summary. And these are sort of the 5 important milestones or markers when we're thinking about a box and whisker plot. So we're going to go through those first. And again, this 5-number summary tells us sort of how spread out the data is. It's going to tell us like so what's the middle, what's the minimum, the maximum, and some other important points within the data as well. So you need to know how to compute these 5 numbers. First one is just the minimum value. Obviously, that's pretty easy. All you need to do is just order the data from least to greatest. Minimum value is pretty easy to identify. One thing that we're going to add to this is we're going to say that the minimum value represents the 0th percentile. The 0th percentile. And we'll talk about exactly a little bit about what percentile means as we move forward. The next number that we're going to compute is called quartile 1, or just Q1. The quartile 1 is the median of the lower half of the data. So what we're going to be doing is dividing our data into 2 halves, and then we're going to find the median of just the lower half. That's going to be referred to as the 25th percentile. The next one we're going to compute is the median, which we already know how to do. That's also called Q2 or quartile 2 as well. And that's just the middle of the data. So the entire data set, we're going to find the middle, and then when we compute the quartile 1, we're going to take that lower half, and then we're going to find the middle of that to find the quartile 1. The median is also the 50th percentile. What this means is that 50% of the data would be at or below the median. The 25th percentile one means 25% of the data would be at or below the quartile 1. The fourth number is called quartile 3, or just Q3. And this is going to be the median of the upper half. So after we've divided it in half, we're going to look at just the upper half of the data and find the median of those values. Think of it as like the 3/4 mark. Quartile 1 would be like the 1/4 mark. This represents the 75th percentile. What that means is 75% of the data would be at or below the quartile 3. And lastly, we have the maximum value, and that represents the 100th percentile. So 100% of the data would be at or below the maximum value. There's 2 other keywords that we're going to look at before we move on to computing some of these. And that is, well, the word percentile. It just means, again, the percent of the data that's at or below that value. So for quartile 3, we would say 75% is at or below this value. 3/4 of the data would be at or below that value. And the other word is the interquartile range, which sometimes we just abbreviate that IQR. The interquartile range, very similar to the regular range. If you remember, the regular range is the max minus the min. The interquartile range is the quartile 3 minus the quartile 1 value. So it's kind of like the middle range. You can think of it in that way. It's the 75 percentile minus the 25 percentile. It's called the interquartile range. It's Q3 minus Q1. All right, we're going to look at one example here, and then your assignment's actually going to be on Delta Math. They have a way that you can get, actually draw the box and whisker plots on there and compute the 5-number summary as well. All right, so in this example, the following dollar amounts are the hourly collections from a Salvation Army kettle at a local Walmart one day in December. So track them. First hour there, maybe 8 a.m. is $19, 9 a.m. $26, 10 a.m. $25, so on and so forth, $37, $32, So that was the amount collected each hour at the Salvation Army kettle. So what we're going to do is compute the 5-number summary and then create a box and whisker plot to represent this data. In this picture over here, whoops. If any of you remember Ezekiel Elliott, he was a player for Ohio State. He now plays for the Dallas Cowboys, but a couple years ago, he brought a lot of publicity to the Salvation Army because after he scored a touchdown, he went and jumped into this inflatable Salvation Army kettle, and it was pretty fun. So that's what that picture's from. All right, so in order to do the 5-number summary, the first thing we need to do is order this from least to greatest. So just like we've been doing in a lot of these, I'm going to go ahead and write these out. Hopefully I don't miss one here. Good news is when you do this on Delta Math, they've already ordered it for you. All right, so there we go. So the first thing, the easiest ones actually to identify are the min and the max. I like to just go ahead and write those first. So the min is obviously 19. We're gonna then want to do a quartile 1. We're gonna list these. A median, quartile 3, and a max. So that's our 5-number numbers, our 5-number summary. All right, so our max is 39. That's 2 of them. And then I like to do the median next because you kind of need to know where the middle is in order to do quartile 1 and quartile 3. So to find the median, if you remember, sort of the way we figure this out is count how many values there are. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So what you do is you do 12 plus 1 over 2. That's 13 over 2, which is 6.5. This tells you the position. The median isn't 6.5. I had a few people do that on some assignments. That's not the median. That's the position of the median. So we go to 1, 2, 3, 4, 5, 6.5 means right here. That's where the median would be. It's a good idea to just draw a line there. Now to find the median, what we do, since it's not one exact number, is we take the average of these two. We take the average of the 6th and the 7th. So you could add those and divide by 2, or you could just know that the middle of 28 and 29 is 28.5. But again, what you could do is 28 plus 29 over 2. Averaging of those, you get 28.5. So that's our median. So now for the Q1, I'm just emphasize that line in the middle there. We want to find the median of the lower half. So just look at this half of the data and find the median. Well, we've got 1, 2, 3, 4, 5, 6. So the middle is going to occur at, if you want to write it out, 6 plus 1 over 2. That'd be 7 over 2. That means the 3.5 position. Okay, 1, 2, 3. So it's going to occur right here, which means we need to take the average of these two. The average of 23 and 25 is going to be 24. It's right in the middle. So quartile 1 is 24. And then lastly, we need to find quartile 3. So that we're going to be looking at this upper half of the data. Just like before, there are 6 values, so the middle is going to occur right here. We want the average of 32 and 34. So that's just going to be right in the middle of those two is 33. So that is our 5-number summary. There actually, you can get this data as well on the, if you do the 1-variable stats on your calculator. If you were to type all this in and do the 1-var stats like we did previous sections, it tells you this information as well. All right, and now that we have this, to make a box and whisker plot, there's not really an exact science to it. You're not going to have to draw any of these for our assignment, but basically how you do it is you start with a number line, and I start with generally the lowest value, which is 19. Put 19, and then just count 21, 22, 23, 24, 25, 26, 29, 30, 31, 32, 33, 34, 36, 37, 38, 39. All right, so label the lowest and the highest. And then let's go ahead and label the other ones that we're going to need. So quartile 1 is at 24, so 20, 21, 22, 23, 24, right here. 25, 26, 27, 28, 29, so 28.5 is going to be right there. 29, 30, 31, 32, 33. And if you wanted to label all of these, you could. and then 39 is up here. So those are our 5 numbers on our number line there. Just put little dots there. And then we're just going to draw our plot here. Change colors. So we're going to go down below it. We could do above. Doesn't matter. I'm going to put at 19, just kind of down here, put a dot. And at the end, I'm going to put a dot. Put a dot here. Put a dot here. A dot here. And then for the median, I'm going to draw a line down the middle. And then same with the quartile 1 and quartile 3. Just draw lines, kind of make them even. And then you're just going to draw a box. Mine's not going to be amazing here, but like so. Oops. So that's the box. And then the whiskers are these lines that reach out. You just connect these. Those are the whiskers. So this is our men. This is quartile 1. This is our median, quartile 3, and our max. And that is a box and whisker plot. If we wanted to answer a question like what's the interquartile range, let's go ahead and do that as well, the IQR, interquartile range. What you do is you do Q3 minus Q1. So it's 33 minus 24, which would be 9. If we were asked just the general range, we could answer that as well. Just do the max minus the min, 39 minus 19, which is 20. So those are typical questions you're asked. You're also going to be asked questions about the percentiles. So we'll go ahead and get into that on the Delta Math assignment. Let's go and flip there. So the first part of the assignment is going to be creating a box and whisker plot. Now it's already done that for you. You're just going to fill in this 5-number summary and then drag it accordingly. Also on all these is already put them in order from least to greatest for you. So it's not too bad here. I'm going to go ahead and list the min, which is obviously 6, and the max, which is 19. Next up would be to find the median. So I'm going to count how many values there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's 12. That means the median is going to occur at 12 plus 1 over 2. That's 13 over 2, which is 6.5. So we want to go to the 6.5 and draw a line. 1, 2, 3, 4. 6.5 would be right here. It doesn't look like the middle, and that's because, well, there's 2-digit numbers on the right half, and the left half has some single-digit numbers. But it is the middle value there, which means the median is going to be the average of these two, 10 and 11. Well, the average of 10 and 11 is just 10.5. Probably did that one in your head. Type that in. Next up, we need to find quartile 1. So we're going to take this lower half and find the median. Well, there's going to be 6 values there. So the median is going to occur between 3 and 4, right there at 3.5. So that's going to be the average of 9 and 10. So that'd be 9.5. And then lastly, the quartile 3 is going to be middle of this half. And right in the middle of the 3rd and 4th, between 12 and 17. For that, maybe what you want to do is actually write it out. You do 12 plus 17 over 2. So that gives you 29 over 2. And that is 14.5. So that's right in the middle of 12 and 17, 14.5. So there's our 5-number summary. The next thing we need to do is drag this to make it fit these values. So just start with the min. That's going to represent here. We're going to drag that to 6. And actually, we're going to have to move this over a little bit to get there. So we're going to drag this to 6. Quartile 1 at 9.5. So we want it right between 9 and 10. You can see there. Well, quartile 1 is going to be this value. The median's at 10.5. So it just needs to move up a little bit, right between 10 and 11. Quartile 3 is at 14.5, so right between 14 and 15. And the max at 19, it looks like it is good. So what you can tell based on this is see how the bottom half is a lot more bunched together. So what that means is that the bottom values are closer together. And then here we got this long stretch. That means the top half of the values are more spread out. So the data is closer together at the bottom half, and then the top half is more spread out. And you can see here we got like this jump from 12 to 17 to 19. There's definitely a bigger difference in the second half, whereas we've got 6 only gap of 3, 9 to 10 is only a gap of 1. So there's definitely less spread in that lower half. All right, and that's all we have to do. Just answer those. Let's go ahead and submit. All right, and we'll do one more here together. So first thing, again, I always do would be write the min and the max, 4 and 16. We then need to find the median. So let's count how many values we got. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 values. So we could do 14 plus 1 over 2. It's 15 over 2. That means we're going to be looking at position 7.5. So between 7 and 8. 1, 2, 3, 4, 5. Right here. 1, 2, 3, 4, 5, 6. Yep, just double checking there. So we should have 7 on each side. 1, 2, 3, 4, 5, 6. It's always good to double check those. So we want these two values, 9 and 9. Well, the average of 9 and 9 is obviously 9. That's easy enough. We then need to find quartile 1. That's going to be the median of the lower half here. And there was 1, 2, 3, 4, 5, 6, 7 values. Yeah, so we would want position, if you want to do this, 7 plus 1 over 2. 8 over 2, which would be the 4th position. Yeah, 4th position, 8 over 2, which is 4. So 1, 2, 3, 4, which would be right there. 7. We've got 3 on either side. Quartile 1. So that one does have it exactly in the middle. In this upper half, we've also got 1, 2, 3, 4, 5, 6, 7. 7 plus 1 over 2 tells us in position 4. So in this upper half, 1, 2, 3, 4 would be this value, 13. Really take your time on that, because if you miss one of these, then you'll miss the whole thing. All right, now that we've got those, we can drag them. So the min needs to go to 4. Quartile 1 needs to go to 7, so this line goes up to 7. Quartile, or the median, which is quartile 2, is 9. Quartile 3 needs to be at 13. And the max is at 16. All right, I think that's good. Let's go ahead and give it a shot. All right. So that does it for the box and whisker plots. I believe you have 5 of these to do. So just take your time again, do your best. Now there is a couple other sections here where you're gonna have to answer some questions about the box and whisker plots. Hopefully these should be pretty easy. They could range from, in this case, what's the median? So all you do is find the line that represents the median, which is this one right here, and then find where that is on here. So it looks like this is going by, see, looks like this is going by 2s. That's generally the hardest part, is figuring out what scale this is, these number lines are. But this is going by 2s, I think, because we got 42, 44, 46, 48, 50. Yes, so it's going by 2, so this would be 42, 44. The median would be at 44. Okay, another question could just be the minimum. So you just need to know that this represents the minimum here. Figure out what that is. Looks like this is going by, let's see. One, two, three, four, 5. It looks like this is actually going by 4s, which is kind of a bizarre scale. Because if you were to count, this would be 24, 28, 32, 36, 40. The best way to figure out the scale, I guess, on this one, and it's kind of hard, is to just take 2 values, say this one, 40 and 20, do 40 minus 20, and divide it by how many sort of ticks there are in between. So if we were to start at 20, it would be 1, 2, 3, 4, 5. It's like how many steps you'd have to take. So that would give us 20 divided by 5, which would be 4. So that tells us each tick is 4. All right. Didn't realize it'd be that challenging actually to figure out how to read this one. So that means we've got 0, 4, 8, 6, 12, 16. So this would actually be at 12. I don't think they're all that challenging, but this one happens to be. All right, next question you could have would be an interquartile range. Interquartile range, remember, is Q3 minus Q1. That's going to be, here's Q1, here's Q3. We need to figure out those two values. It looks like this one's going to be 4 again. All right, so it's the same scale, so at least you already know what it is. So this would be 24, 28, 32. This is at 32. This one is 64, 68, I believe. So it's going to be 68 minus 32, which would be 36. All right, so that's pretty much the gist. You could have, again, any number of questions. It looks like this one is actually by 5s. Again, how you could figure out these scales is just take two values. Let's just say 20 and 40 again. You just do 40 minus 20, and then like divided by how many steps you'd have to take to get here. So here you got 1 step, 2 step, 3 step, 4 steps. So it would be 20 divided by 4, which would be 5. So each tick mark represents 5. So the range would be 0, so this would be 5, the men, 10, 15, 20, 25, 30, 35, 40, 45. So the range would then be 45 minus 5, which would be 40. So that looks like to be the hardest part, is just figuring out the scale. And then there's one other set here which asks you very similar things, except I believe this one asks you some questions about the percentile. 1 and 2, 5. All right. Yeah, so on this last one, we're asked some questions about the percentile. What percentage of the data are greater than 140? All right, so to do that, answer that question, all of these questions are going to be about one of the values, whether it's the min, quartile 1, median, quartile 3, or the max. These numbers are going to be referencing one of these. So in this case, 140, that's going to be the median there. That's going to be 140. So if it asks what percent of the values are greater than 140, well, 140 is right in the middle, right? So that means there's 50% of the data on the left side, and there's 50% of the data on the right side. Even though it doesn't look like they're even, we know that the median splits it in the middle, so half are going to be on the left, and then half are going to be on the right. So there would be exactly 50% that would be greater than 140. So that's going to be our answer. Yeah, and you'll see, I actually showed you a little graph. I should have kept it there. But it kind of divides this into different sections. It's a good way of explaining it. You can think of like 25% of the data in this section. There's 25% in this section. There's 25% in this section. And there's 25% in this section. So think of these box and whisker plots as like quarters. Each quarter represents 25% of the data. All right, so the next one asks what percent are greater than 60. So 60 is going to be right here. So what percent are greater than 60? That's going to be this way, right? Bigger. So that means 25% are greater than 60. So we have to answer 25. That's another greater one. Let me try that. So most of these are greater than. And just want to focus on percentile questions here. All right, so I guess they're all pretty much greater than, so they're greater than. Yeah. All right, so what you're going to be doing for those percentile ones, I think I'm actually going to eliminate the different ones and just focus on percentiles. Yeah, because I'm not good enough. All right, there we go. There's another one. What percent is greater than 80? So then what you want to do is find 80. That is quartile 3. So greater than 80 is going to be to the right, which is 25% of the data would be there. All right, hopefully that part makes sense to you. Take your time on this. I think I'll make this actually maybe 3 days worth of work with the add puzzle and then the assignment. Here's a different one. Okay, let's see this one. What percent of the data values are between 50 and 75? So let's mark those two places, 50 and 75. This is going to be 45, 50. So 50 is here. 75 is going to be here. So what percent are between 50 and 75? Well, remember, there's 25% here, 25% here, 25% here, 25% here. So the percent between 50 and 75 would be a total of 50% of the data. Half of the data is between those. 50%. Right. And again, there's a good little graphic there. It shows it divided into sections of 25%. So that's the best way to think of it. All right, if you're struggling with this, be sure to reach out to me and let me know, and good luck.